just before the launch, when you deploying the software, this particular software which actually triggers these error codes, they may have some malfunction. It is very hard to figure out where the software is wrong and it is triggering a lot of error codes. So it is other way around. If you can't figure out a software fault, you actually use the data to figure out that where is the software fault. Very interesting. So it's just basically the BI kind of approach here, but I'm not going to talk about that. But this is more about the predictive approach where we used it to really figure out a software fault. So how do we really how we did it? We actually formulated this as a classification problem. We said that, hey, give me the error codes on which you have the fault, which is a software fault, and it's kind of intermittent, and then you give me the one of the baseline, and then we will say that, hey, these are my two classes, and then we will figure out what are the parameters which are important. So just a classical algorithm, but we give a twist to it, and that's where you need a data science skills to do that. Is basically one decision tree was not enough, because ultimately you need to rely on the domain knowledge. How do I capture that domain knowledge? Is that you need to show one tree, not just a one tree. You need to show him multiple trees. So this is like one of the tree which actually shows that how we classify a baseline set of code versus the intermittent code, and then you show a whole bunch of other trees, and this is a variant of a random forest, but the objective here was not really classifying. Objective was here to give a visualization tool to an engine expert so that he can say that, hey, this is what is happening wrong, and ultimately his knowledge will be used. So that actually may also raise another question later on. You can interact with me how much of domain knowledge we data science can really leverage without having a human in the loop. So we can talk about that. So one of the things which you can look at in this particular thing is that actually these engine control module and the powertrain relay voltage actually had this kind of a highly skewed sort of one of the skewed distribution and one of the Gaussian kind of thing. And with this kind of a distribution, engineers were able to figure out that this problem is happening more at a startup of the vehicle, and that was more of a domain knowledge. It was hard to figure out from the data. Another thing is, can we figure out the pairs? If I have 500 parameters, if I need to find out correlations which are very interesting, it's very difficult to find out, just keep on computing pairwise. But can we do some pruning and do some pruning and then say that, hey, here are the pairs which are informative. So just use the basic skills of computing, doing a linear regression fit. And another thing which was very interesting for the domain guys were to having some kind of a constants also. If those kind of relations are there, that was also interesting. So we kind of leverage that how many points are on this line and how many points are here, and I compute a coverage number and use that for pruning. So we use that for pruning here. And another one is, we can rank these pairs based on these R square values, or based on the using these coverage values as well. So this was like, how do we kind of remove some of the things automatically which may not be informative. And in fact, before that also the question comes that what do you mean by informative? So there you need to have a dialogue with the domain guy and the business, and then you translate that into a data science problem. So the business impact, definitely it was a significant business impact. There was some kind of awards and all those things came up after this, and we reduce the analysis time from 3 to 5 days to a couple of minutes, because we had some kind of a predictive tool which can really say that, hey, here are the pairs which are informative, and this is what is happening wrong in terms of showing it as a tree. So, well, I told you I'm not gonna hold you for a long between your lunch and myself. So lunch is waiting for you guys. Here is my Twitter handle and my email address. But here's one more advertisement I would like to make. If you want to go in a hardcore data science conference, there is a one coming up, IKDD, and you can go over there. So there are, I think, I don't know, do we have
Yes,
time?
we have about 10 minutes of time, so
Okay.
we can have a
Maybe we can take few questions,
Yes,
and I don't
yes.
want to hold between the lunch, and we can do it offline.
Hello, you talked about the decision tree analysis that you did, and it was very similar to random forest, right?
Right.
So, how was it actually different from creating a random forest and what you did?
Yeah, so the difference here was that actually, number one, like in the random forest case, the attributes can reappear. In this particular case, actually, we wanted to make sure that your trees are disjoint. So whatever you see here, the parameter what you see here, it should not reappear here. So that was one of the things. And then second thing is that the objective of random forest was to maximize your uh, classification by ensembling various trees. Here it is more of a cascading. So I'm just running a one tree and getting what is my attributes which are important, and then I show that, and then I remove those parameters, and then I again do my classification, and then show that one, and then I keep on doing it. But at the same point, we cannot show more trees. We need to limit it. How many to limit, right? And the another thing is that whenever you are showing a tree, you don't want to show a lot of complex trees as well. So you need to limit the growth of a tree. So a lot of pruning also you need to do. And another thing is that objective itself is totally different. It's not really maximizing the classification. It is all about mixing the visualization with the showing the multiple trees. Yeah, so Vijay is here. I was actually calling you. There was a one uh, comment that the, there are guys who are getting older machine data scientists. You need to also acquire the new skills, which I kind of agree that when the changes are the technology is at a very faster pace, and we as a data scientist, we need a blend of the newer skills, and then whatever we did in our older jobs, how do we leverage that to do the yeah. So actually, yeah. So Vijay question is that actually Vijay is gonna have a talk tomorrow, so I'm advertising for you. So a very fantastic talk about deep learning. So his question is, which language to use and all that. So my game is that, hey, let's look at the product. So if I'm shipping a product, so I have been sitting in a product organization. So whatever is the product needed. So if the product needs in a Java language, let's build it in a Java. If product is can leverage more in a Python, okay, I will do it in that. So more to do with the seamless deployment, and have a less version and that. So that's the way. And another thing is that more of the things are okay. Let's look at the problem and change the algo. So that's the theme I have been primarily working throughout my career. Go ahead. Yeah. So I think it is very very much important, and things are so deep in every word. Now if you say that, hey, how much I know about D3JS or Node.js or whatever other, you can throw me a whole bunch of other words as well. AngularJS. I mean, what I think as a data scientist, you can have a leverage of, there can be some visualization engineer who may be just developing that. But as a data scientist, what you need to know is what is the algo which I'm going to write so that, it can enable that kind of a visualization. So let me give you an example. Let's say you have a Twitter data coming in, all the streaming data coming in, and just imagine this conference. So if we have a Twitter handler for that, and there are a whole bunch of guys tweeting it, hey, Saddam Singh giving that, interesting talk, come to this one, leave that conference, leave that room, come here. And you want to see all that visualization happening in the real time. How are you going to visualize all that, right? I mean, you can actually maybe visualize it as a river of words. Now, if you need to design as a river of words, either as a data scientist, am I going to do that? I think, as I said, you need to be all-rounder, but at the same time, you're going to work with others, right? So you're going to work with a visualization engineer, and who is going to actually code that up, but your algo should really, give detect those topics from those Twitter streams, and then it will say that, hey, the topic is Satnam Singh's talk at this point, and that that has to be spitted out, and then it can be visualized. So what I see as a data scientist role is going to be more towards that, and I know there are a whole bunch of guys, they say no, data scientist is also going to code up that visualization as well. Maybe, yeah, I have seen a couple of talks where let's say you are working in a particular domain of medicines or biomedicine, right? And now you need to visualize the correlations between say 500 parameters, and you can come up with some beautiful visualization, and you can code that up. Definitely, I mean, that could be another thing. And so what I feel is that at some point as a data scientist, you need to see, hey, what are my strong points, and where I can play my cards and get a bigger paycheck. Isn't that so?
Question here.
Yeah.
Yeah, question here. So you have talked about the pruning of a decision tree.
Right.
So too low, it will end up in having a more classification. Too high, you will end up in small decision.
Yeah. Right.
But the problem what we face is at what level we have to cut the tree.
Right.
So you talked about some kind of
Right.
algorithm. Can you throw light on?
Yeah. How about we take it offline? And maybe I can give you more deeper as well. So okay, we can take it offline.
Yeah. Second question is you have talked about.
It doesn't mean that I
application
don't know the answer, but
Yeah, I completely agree. Yeah,
it's okay. I mean,
yeah.
I can give you 5 other algorithms, but it's not just marketing talk. So I can get you that, but in view of everybody's time for their lunch, I just want to. I'll
Yeah.
take it
Second question is you talked about the application performance, like
Sure.
you crunch the data from the logs and then
Right.
what kind of problems you are solving then?
That also I'll take it offline, because
All right.
I am not allowed to talk too much about that.
All right. Thank you.
Okay. You guys might be thinking, if I ask a question, this guy may say, let us take it offline. Okay, no, it's okay.
Yeah, just last one before lunch.
Okay. I was a little curious to know more on the automobile use
Yeah,
case that you
sure.
presented very
Right.
well. In the organization that I'm working, we are starting afresh. So there is no role of data scientist when we asked a question that how many of you want to become a data scientist. So we are all setting this up from scratch.
Can I give up some consulting to you?
I think
Okay,
I'm vouching
sure,
for
sure.
it. So
Yeah.
the question
All,
though
everything
is
is getting recorded, so it's okay. Go ahead.
yeah. So the question though is similar use cases.
Yeah.
I would like to build, or I would like to have it seen somewhere if there are already built, which I don't want to do it again.
Yeah.
Which meant to say that you talked about the fault failure and
Right.
how do we predict it.
Right.
But there are so many other factors encompassing a particular vehicle, which means
Right.
the marketing, the sales,
Yeah.
other factors that
Yes.
can improve the organization and bring
Right.
value through predictive analytics
Right.
from the real-time data
Right.
or batch-wise data.
Right.
Do we have use cases like that,
Yes.
or can you point me to that, or can you share one of yours so that I get some enlightenment of what I can possibly do?
Yeah. So actually, yeah, your question is more that, hey, I only talked about just 10% of the problem actually,
Mhm.
because I'm looking at the faulty data and kind of error codes and the parameters, and then I'm trying to do some predictive maintenance kind of thing, or infer software faults. There are other use cases are predicting the vehicle sales itself, right? So that you need to take it the data further way up in the stack. So you know there were actually uh, 20, 15 PhD scientists working in this particular organization, doing whole bunch of gamut of these use cases. So this is one of them is predicting what, and not only that, which vehicle to design, which vehicle to really build. That also you can leverage through the data. That is another use case. Then another one is you have all these um figuring out customer dissatisfaction, or doing all kinds of the all-time highs, giving say tire pressure monitoring, right? So I do through sensors. That's more of IoT use cases. I put all whole bunch of sensors and then do a real-time processing and say that, hey, this is about to your tire pressures are running low, or let's say you are planning some trip to Kurg, and you would basically press a button and do your telematic solution should actually tell back and say that, hey, your car is good enough to drive to Kurg. You really don't have any issues, or this kind of issue may happen. That also it should figure out that. So there are whole gamut of things. So my favorite answer. Let's take it more interaction afterwards.
So
Okay, so
thank you.
enjoy your meal, and I hope
Yeah, just spare a while before going and having your lunch. So just
he's gonna give a certificate. Yeah.
yes,
Okay.
that's correct.
Thank you.
So a round of applause for Satyanjay.
Thank you. Thank you very much.
Thank you. So we're really sorry. I can see hands raising up for questions, and for the time constraint, we cannot take all of your questions. But I'm sure offline he can answer. And you guys were so interactive. And even if Thakur of Sholay was here, he would also raise his hand. So, anyways, on a serious note, the next session was supposed to be taken by Punit Gupta. Now he has a family emergency. For that, he is not going to turn up today. So apologies from his end and our end as well. So on the other hand, the conference will be going on the other end, where you can go and attend Ankur Gupta. He would be talking about big data use cases, which is about speeding up data workloads. So we'll be going for lunch. Enjoy your lunch. It is across to the dining hall across this lawn, and we'll see you back. Thank you.
Consumer goods and retail and Genpact. He comes with overall experience of 20 years, and then he would be throwing some light on the best practices around big data analytics for your organization. So over to you, Mr. Tanmay. Thank you.
Okay, thank you, Siddharth, right? Can you hear me? Okay, great. Thanks, Siddharth, and thanks to all of you for being here. Okay, so before I start, see, you've heard a lot of, and I was here for half a day now, you heard a lot about Hadoop and Hive and Java and Storm and Python and all kinds of stuff, like almost an Animal Farm was there. You also have a Mahout